So I successfully completed the task 2 of the data science and business internship at the Sparks Foundation, and the title was for this task was the prediction using unsupervised machine learning, and the objective for this task was that from the given iris dataset we have to predict the optimum number of clusters and represent it visually. So first I've loaded the data using pandas library, and here is the first 5 rows and columns of the data set. And I here using the info we can get the more detail about our dataset, as it contains 150 entries and 6 columns, as you can see, out of which 5 were useful for us, 4 being the numerical or quantitative values, and the fifth is being the categorical value. And using the describe we can see that the sepal and the petal are equally, not equally, sepal is generally like a little more large than the petal, but it is both are large, which is a specialty of iris flowers, that the sepal and the petal are equally large in that species. And when we apply a unique function in the species column, we get to see that there are 3 unique species present in the dataset: iris setosa, iris versicolor, and iris virginica. And using the value counts we see that each classes has each 50 instances in the data sets. And using the pair plot, here I'm plotting the relationship between each columns of the data set. And coming to the predicting the optimum value of k for clustering. So clustering is like the grouping of data points, grouping of our data into different groups, specify the number of groups which we specify. So the number of clusters which we want to form is generally known as the value of k, which we generally give, or which the value of k we get through some of the methods which will look below. So first I have separated the data species column to the categorical value, and when I scatter plot we can see through our eyes that there are 3 clusters forming. But generally when the data sets are huge and unlabeled, we cannot just see through our eyes and predict the number of clusters optimally it should form. So we use k-means algorithm and some other method to predict the optimum number of clusters that should be forming. So first what is the k-means algorithm and how it works. We take an example and we just randomly set the cluster size to 2, and when we predict and plot it, we can see that it divided our data into 2 clusters. So how does this k-mean algorithm works? So what it does, it plays that the k number of values into the place the k number of values, or which we can call centroids too. And what after that, in the step 2, each data point's distance, Euclidean distance, is calculated from that point to the centroid, and the distance which is minimum out of the 2 centroid is that so that data point is assigned to that centroid. So now coming to the how we can find the optimum number of optimal number of k value. So what I'm here going to do is that I'm looping, manually iterating through range from 1 to 11, and I will put the size of the clusters, and for each cluster size I will append its inertia to the inertia list, and I will plot through it. And what is inertia generally is, it is the Euclidean distance from a data point and a centroid and the sum of square of it. So generally the optimal value is that when the number of cluster is less and the inertia is less. But the twist is that as the number of cluster increases, inertia also decreases. So generally we select the point using a method known as a elbow method. So we select a point where after that point the inertia, the rate of decreasing of inertia starts getting slow. So here's the point. You can see that it also forms an elbow like shape, thus we also call this method an elbow method. And after this the inertia starts slowly decreasing. So we select the optimal number of clusters of value of k as 3. So now if we put our k value as 3 in our k means model, we and after we predicted it, we can see that it successfully divided the data into three parts, into three clusters. So